All right, class, this is section 2.2. We're going to be talking more about sets and comparing them. We're going to be looking at equality of sets. So here we go. Set equality. We have a definition for equal sets, and sets are equal when they have exactly the same members. In this case, we can write A equals B. Set A equals set B. If A and B are not equal, we write that they're not equal with a non-equal sign in the middle of them. So which pairs of sets are equal? So this is problem A. So we've got all the blood types, and all the blood types here again are just in a different order. So we can say that these are equal sets. Even though they have different order to them, they are still equal sets. So let's talk about B. So again, this is set A, and it is equal to set B. So here's set A. A is defining X, such that X is a citizen of the United States, and B is defining that Y is anybody born in the United States. Well, we know that anybody born in the United States is a U.S. citizen, but if you take someone like our former governor, Arnold Schwarzenegger, he was not born in the United States, but he is a citizen. That's why he could be governor of California. So these sets are not equal, so A is not equal to B. Even though a good portion of B is in A, they are not equal. There's more numbers sorry, I was looking at it the other way. There are more things in A. There are more citizens of the U.S. that have not been born here than those who have been born here that are citizens. So equal sets contain the same members. All right, let's keep that in mind as we move forward. So now we've got subsets. Now notice this symbol right here looks a lot like the element symbol, and it's kind of like an element. It's kind of a part of, just like an element would be, but this is not equal, by the way, not subset, but subset uses this symbol here, okay? And so it's saying A is a subset of B if every element of A is also an element of B. So they don't have to be equal, it's just a subset. So the way that this goes, if you look down here, set A is these four numbers, 1, 2, 3, 4. Set B is from 0 to 5. We can see that set A is actually here. So it's kind of like A, the set itself, is actually an element here. It's kind of the way that you can see that. It's kind of an element of B, but it's not really an element. We call it a subset. So we say A is a subset of B. Now, we also will have a symbol that doesn't have the bar underneath it. Now, this bar means it's kind of like less than or equal to. We'll talk about that more in another part. So we've got this symbol down here. Subset is a lot like less than or equal to. And it's not just that it's less than or equal to, it has to be everything in it. So but this idea of less than or equal to is very helpful and similar to what we're dealing with here for subset. So this says find all the subsets of this particular set, 1, 2, 3, and 4. And so what we can do is we can look at different sizes. The subsets here, we could say there's nothing. We could go with a subset of this would just be nothing. Okay? Well, that's one thing. A subset could be 1 as its own little thing, just like we're showing here. A subset could be 2 as its own thing, could be 3 as its own thing, 4 as its own thing. So these are sides of subset 1. So I can circle 1, 2, 3, and 4 as their own little sets. And so there's 4 different subsets of size 1. Now you're going to be asked in your homework, give me all the subsets of size 2. Okay, well, if there's 4 things, then it's like how many ways can you group or get groups of 2? Well, they're all listed out here for you, but it'd be like grouping 1 and 2, 1 and 3, 1 and 4. Well, I just made 3 different sets with 1. That's these first 3. And then you do it again with 2. Okay? 2 can be grouped with 3, with 4, and then finally 3 and 4 will be its own last set. I'm sorry, I circled that one. This is its own last set. So there's 6 different ways that you can make a group of 2 different subsets, or a group of 2 within the overall set called a subset. And then 3, there are 1, 2, 3, 4 different ways that you can have a group of 3 numbers and 3 arrangements. Okay. Now again, look at where we're arranging here. So it's saying I got the group 1, 2, 3, and then I could do 1, 2, and 4, and then I could do 1, 3, and 4. That's all the different ways that I can arrange it with 1, 3, and 4. And then last, the only one that would be left over would be 2 and 4. I can't add any other ones with 1 because I've done all the different combinations with 1 in it. That's why the only last one is 2, 3, 4. For a total of 4 different ways to have a subset of that size. And last, to have a subset, A is a subset of itself. It's kind of weird. If I call this A, I would say A is its own subset because it can be equal to A. So it's kind of like less than or equal to itself, one subset of itself. Okay. So another way to talk about them is where am I looking at here? We've got. Well, I'm sorry, I just threw the definitions up again. So here we're looking at determine whether or not these sets are subsets of each other. So I left the definitions up here for us to work with. So is A subset of B, or vice versa, is B a subset of A? Here I've got 1, 2, 3, and I see 1, 2, 3 there. So A is a subset of B. Now here we've got Jim Parsons, Eddie Falco, Neil Patrick Harris, Melissa McCartney. And then our other set is that X, such that X has won an Emmy since 2010. So all these people have actually won an Emmy since 2010. So our job is to recognize that and say A is a subset of E. But we can't go the other way because there have been more people that have won an Emmy since 2010, and these are not all of them. So it's only A is a subset of E, not E subset of A.